everyone, we are from Team Repo and today we'll walk you through our e-commerce backend project for Product Amin. It is a local business case study we use to build a fully functional Spring Boot API. So this system handles product management with user role, category, and inventory tracking, which is all powered by a MySQL database and a package for easy deployment using Docker. So we choose Spring Boot for its rapid development features combined with Maven for dependency management, while Git and GitHub kept our teamwork organized. So by containerizing this application with Docker, we made it portable and scalable, which is ready for real-world use. Over the next 15 minutes, we'll show you our database design, live API demo, and how we solve all these technical problems.
So this is our database, and the ecom DB database is consisted of 5 main tables, which is the category, product, roles, users, and the additional linking tables that is not shown in this partial dump. So the category table holds product category names. Examples include sauce and condiments, noodles, and health and wellness drinks. The product table store individual products linked by category ID with details like name, price, and the example includes chili giling, mie tarik saffron, and kopi Indochina. The role tables define user roles, specifically admin and customer role, in order to manage access control in the system during the login. And the users table store basic user credentials, including username, email, and encrypted password. So this database supports basic but scalable relational structure to handle product listings, user management, and role-based access for any e-commerce platform.
Hello everyone, I will be presenting the Spring Boot setup for our e-commerce backend application. First, the entry point of our Spring Boot application is the e-commerce backend application class. This class is annotated with Spring Boot application, which enable auto configuration and component scanning. The application starts by invoking Spring application.run, which bootstrap the entire Spring context and launch the embedded server. Next, we have data initializer component. This is a Spring managed bean that run initialization logic right after the application context is loaded. Thanks to the post-construct annotation, its main role is to seed the database with initial data specifically. It creates default user role like admin and customer if they don't exist, and it also creates a default admin user with an encoded password. This ensures that the application has the necessary security role and an admin user ready from the start. Regarding configuration, our application uses the application property file to manage key settings. These include the MySQL database connection details such as URL, username, and password. We configure JPA and Hibernate to automatically update the database schema and show SQL query for debugging. Security setting like JWT, secret key, and token expiration time also defined here. Additionally, the port is set to 8080 and logging level are configured to help us monitor security and application event. Overall, this setup allow our Spring Boot application to start smoothly, connect to the database, initial essential data, and be ready to handle security.
Hello, my name is Salsabila Shafairunisa. My matric is 290267. Now I'm going to explain about Docker for this assignment. This slide shows that the Docker setup I used to containerize my Spring Boot backend project. On the left, you can see the Docker file which I placed inside e-commerce backend folder. It uses the OpenJDK17 image, sets the working directory to /app, copies the compile.jar file from the target folders, and runs the application using java-jar. On the right is a portion of our docker compose.yml file. It defines the MySQL service, set up the database name and root password, and exposes to port 3306. I also mounted the mysql-init.sql file so that the database automatically loads the schema and inserts sample data when the container starts. There's built-in health check to ensure that MySQL is fully up before the backend connects. The backend service, which is located just below this in the YAML file, connects to this MySQL container and runs on port 8080. With this setup, I can start both services together using just one command, which is docker compose up. This is our published Docker image on Docker Hub under the name safsal/ecommerce backend. We push the image here so it can be accessed and run from anywhere without needing to build the project locally. Anyone can put it using the command shown, which is docker pull safsal/ecommerce -backend. This helps simplify deployment and makes our backend application portable and shareable.
So this is the database for the project. Let's see the category. There are 5 categories over here inside the category table, and then inside the product we have over 31 products, which all of it is well categorized in their own category by their category ID. So in the postman we can actually test whether the backend is properly fetched or not, and by using the get functions or query, we can use this to get the categories, the column inside the table of categories, all 5 of these categories, both the name and the ID value of it. And if we want to use or not use, but to fetch the products under a specific category, so for example we are taking ID 4 here, which is oil and herbal products, we are able to get the ID, name, price, category, and also the extension of the ID and the name of the category of the product here. It also goes the same if we try to put ID1, and which is the sauce and condiments over here. We are able to see all of it getting fetched and displayed in the postman.
So one of the key challenges we faced during this project was an issue with Docker deployment that related to authorization. So when we tried to deploy our Spring Boot application in Docker, the web page failed to load. After we investigate, we did discover that this was due to an authorization issue. Our application used Spring Security for secure access, but the Docker container did not have the necessary user credential setup. This caused the page to block the access. So, to solve this problem, we took several steps. First, we reconfigure the Spring Security settings in the application properties file that allow you authorized access. Next, we add the default admin credential as environment variables in the Docker Compose file to ensure that the system had valid login credential. And lastly, we test the secure access using the Postman to make sure that only authorized user could access the system.
As a conclusion, our Spring Boot based on a back-end system for the product admin has effectively addressed the challenges the business faced with the deorganized product management and limited system capabilities. By implementing a secure user authentication, also role-based access control and structured script operation for the product and also category, we are creating a scalable and also reliable solution. The use of Docker and also MySQL ensure the smooth deployment and also data persistence, while our agile approach enable the continuous improvement. The system lays a solid foundation for the future growth, including the potential features like the advanced reporting. That's all for us. Thank you.